Hello friends, you are watching ISC Mathematics and we are solving second exercise of chapter number 5 Matrices, Adjoint and Inverse, ISC Mathematics Standard 12. Okay, before we move further, please don't forget to like and subscribe my channel, share my videos as well. Okay, we were solving part B of second exercise, exercise 5 second part B. Okay, question number 3 was the last question we had solved. So now let us solve question number 4 onwards. Okay, in question number 4, first one is easier, second one we will do. Okay, matrix A is given 2, 3, 5 minus 2. We have to prove that A inverse is equal to 1 upon 19A. Okay, so we have to find A inverse and then we have to check whether A inverse is equal to 1 upon 19A or not. Okay, so in order to find A inverse we need determinant of A as well as adjoint of A. So let us find out determinant of A. 2, 3, 5 minus 2, 2 into minus 2 to minus 4, 5 3s are 15 is equals to minus 19 is not equal to 0. Therefore, A is an invertible matrix. Clear? Okay, now so A is an invertible matrix. Now we will find out adjoint of A. Now we know how to find adjoint of A of a 2 by 2 matrix. Okay, we interchange the diagonal elements and we will change the signs of off diagonal element. So minus 2, minus 3, minus 5, 2. This is the adjoint. Now let us put the formula to find A inverse. A inverse is equals to 1 upon determinant of A into adjoint of A is equals to 1 upon determinant of A is minus 19 into adjoint of A is minus 2, minus 3, minus 5, 2. Taking minus 1 common from the matrix, we will get 2, 3, 5, 2, minus 2. Okay, now this matrix obtained is matrix A, so which is equal to 1 upon 19 into A. So hence we have proved that A inverse is equal to 1 upon 19A. So this is the second of question number 4. Now let us solve. Okay, now question number 5, similar questions are there. Evaluate the polynomial 2a square plus 3a plus 5i. This sort of questions we have already done. Okay, so question number 6 I will do. Find the inverse of the matrix. You are given a matrix and we have to find the inverse. Okay, question number 6. We are given a matrix say A. Let us name the given matrix to be matrix A. Row wise entries are 6, 7, 4, 5. Okay, we have to find the inverse of this matrix, and then using the inverse we have to solve the system of equations. 6x plus 7y is equal to 2 and 4x plus 5y is equal to 3. This is a board question, ISC 1985. Okay, so let us find out the inverse of matrix A. So for that determinant of A we will find first. Okay, is equals to 6 5 is 30 minus is equals to 2. Okay, so this is not equal to 0, hence A is invertible. Now adjoint of A is equal to 5 minus 7 minus 4 and 6. So this is adjoint. Okay, now let us find out A inverse. A inverse is equals to 1 upon determinant of A into adjoint of A is equals to 1 upon 2 into matrix 5 minus 7 minus 4 6. So this is A inverse. Okay, so now we are given a system of equation. Let us number this equation or result to be result number 1. We are given a system of equations 6x plus 7y is equals to 2 and 4x plus 5y is equal to 3. Okay, now writing as a matrix equation 6, 7, 4, 5 into xy is equals to 2, 3. Okay, so obviously the matrix obtained in this equation is matrix A only, and therefore we can easily solve. Okay, finding the solution means finding the values of x, y. Okay, let us denote. This is already denoted that by it is already named to be matrix A. Let us consider that this is matrix X and the second one to be matrix B. Okay, so let X is equals to matrix containing elements x5 and B is equals to matrix containing elements 2, 3. Now Ax is equals to B we can write, therefore X is equals to A inverse B, and therefore X is equals to A inverse is 5 minus 7 minus 4 6 and matrix B is 2 3. Therefore X is equals to 5 2s are 10 minus 7 3s are 21 and 4 2s are minus 8 plus 6 3s are 18, and therefore X is containing elements x and y. Okay, 10 minus 21 minus 11 and 10. Yes or no? So value of x we got to be minus 11 and value of y is 10. A inverse 1 by 2 is given outside the matrix. Yes or no? So we forgot to write down, no problem. Let us put outside 1 by 2. So minus 11 by 2 and 5, which is the correct answer. Therefore x is equal to minus 11 by 2 and y is equal to 10 by 2. Therefore x is equal to minus 11 upon 2 and y is equal to 5. So these are the required solutions or values of x and y. So question number 6, first one we have completed. Let us solve the second question of question number 6. Okay, question number 6. Number 2. We are given a matrix. Let us name that matrix to be matrix A. So matrix A is given 0.8 minus 0.6, 0.6 and 0.8. Okay, we have to find the inverse and then we have to find the solution of the given system of equations. Yes or no? Okay, so let us find out the determinant of A. 0.8 minus 0.6, 0.6, 0.8, 0.64 plus not equal to 0. Therefore, A is invertible matrix. Okay, now we will find out adjoint of A. Adjoint of A will be obtained by interchanging the diagonal elements and changing the signs of diagonal elements. So we got adjoint of A. Now we can calculate inverse of A. Now A inverse is equal to 1 upon determinant of A into adjoint of A is equal to 1 upon determinant of A is 1 only, and 0.806 minus 0.6, 0.8, 0.6 minus 0.6, 0.8. So this is the inverse. Okay, now system of equations is 0.8 x1 minus 0.6 x2 is equal to 10. 0.6 x1 plus 0.8 x2 is equal to 20. Now this system of equations can be expressed as a matrix equation in this way. 0.8 minus 0.6, 0.6, 0.8 okay is equals to clear. Now the first matrix is obviously matrix A. Second matrix will consider to be X and third matrix to be B. So let us write down. Let X is equals to matrix containing xy and B is equals to polar matrix containing 10, 20. Okay, now Ax is equals to B implies X is equals to A inverse B implies X is equals to A inverse is 0.8, 0.6 minus 0.6, 0.8 into B is 10, 20. Therefore x is equal to 0. 8 plus 12 and minus 6 plus 16. Okay, therefore now matrix X is matrix containing elements X, Y and 20, 10, and therefore X is equal to 20 and Y is equals to 10. So we got the solution. The values of X and Y are respectively 20 and 10. Okay, actually it was in the question x1, x2. So in place of x and y, you write down x1, x2. Clear? So question number 6, second one is also over. Okay, question number 7 now. It seems that there is some mistake in the question. A square plus bc plus something d is given into 1, but actually it is not d. So a square plus bc plus 1 into I minus a into a. Okay, the question is like this. So let us solve this question now. Question number 7. Let us solve now question number 7. Okay, so let us solve question number 7. We have to find the inverse of matrix A, B, C, 1 plus BC upon A, and we have to show that A into A inverse is equal to A square plus BC plus 1 into I minus A into A. Okay, so in order to find A inverse, first we'll find out determinant of A. Okay, so determinant of matrix A is 1 plus BC minus BC is equals to 1, not equal to 0. Therefore, A inverse exists. Now, adjoint of A we have to find. So 1 plus BC upon A minus B minus C and A. Okay, this is adjoint of A. So now let us find out A inverse. 1 upon determinant of A into adjoint of A. Okay, 1 upon 1 no need to write. So the adjoint is the Clear? Now we got A inverse. Now we have to show that A into A inverse is equals to A square plus BC plus 1 into I into minus A into A. So now we will find out A into A inverse is equal to A into 1 plus BC upon A minus B minus CA is equal to 1 plus BC minus AB minus AC and A square. Okay, so this is one side. Left side we have calculated. Now let us calculate the right hand side. So this is equation number 1. Now A square plus BC plus 1 into I minus A into A square plus BC plus 1 into 1 0 0 1. I is an identity matrix of order 2 here. Okay, minus A into A B C 1 plus BC upon A. Let us simplify. So A square plus BC plus 1 0 0 A square plus BC plus 1 minus A square AB AC 1 1 plus BC. Okay, now let us subtract. So when you subtract first minor corresponding element, so A square will get cancelled. We will get 1 plus BC. Okay, then minus AB, then minus AC, and finally 1 plus BC will get cancelled. We are left with A square here. So now look at, now you can compare the first and the second results. You will find both are equal, and therefore from 1 and 2 we can say that A into A inverse is equal to A square plus BC plus 1 into I minus A into matrix A. So final statement we will write down. Therefore from 1 and 2 we can say that A into A inverse is equal to A square plus BC plus 1 into I minus A into A. Okay, so this question 7 is also done. Now let us solve the next question. Okay, now let us solve the first one of question number 8. Of question number 8. Okay, suppose the demand curve for automobiles over some time period can be written as x1 is equals to 15,000 minus 0.2 x2. Okay, where x1 is the price of automobile and x2 is the corresponding quantity. Supply curve is given by x1 is equals to 600 plus 0.4 x2. Okay, now using matrix theory we have to obtain x1. Okay, so obviously matrix equation we will write down for this. Let us first convert these equations into standard form. X1 plus 0.2 x2 is equals to and x1 minus 0.4 x2. Okay, in this form we can write the two equations, and now we will write in the matrix we will write a matrix equation for the given system of equations, that is 1 0.2 1 minus 0.4 x1 and x2 is equals to 15,600. Okay, first matrix we will take to be A 1 0.2 1 minus 0.4. X will be the matrix x1 x2 and B will be the matrix 15,600. Okay, done. Okay, now first we will find out the determinant of A. Okay, so the matrix equation will be Ax is equals to B, and therefore x is equals to A inverse B if A exists. Let us find out determinant of A. Minus 0.4 minus 0.2 minus 0.6 not equal to 0, and therefore A is invertible matrix. Okay, adjoint of A we can find out by interchanging the diagonal elements and only changing the signs of diagonal elements. So minus 0.4 minus 0.2 minus 1 and 1. Okay, done. So this is adjoint. Now let us write down the inverse. Okay, now A inverse is equals to 1 upon determinant of A into adjoint of A. Adjoint of A is minus 0.4 minus 0.2 minus 1 1. Okay, so minus 0.4 minus 0.6 2 by 3. Clear? Then 1 by 3. Okay, minus 10 by 6, so 5 by 3, and this will be minus 5 by 3. Okay, so this is A inverse. Okay, now we can find out X is equal to A inverse B. Okay, now X is equals to A inverse B. Therefore, X is equals to A inverse 2 by 3, 1 by 3, 5 by 3, minus 5 by 3, and B is 15,600. Okay, therefore X is x1, x2 is equals to, okay, 3 5 are 5 5 2s are 10,000 plus 200. Okay, 10,000 plus 200, and second will be 5 5s are 25,000 minus 2 5s are 10,000. Okay, so x1 x2 is equal to 10,200 and 25,000 24,000. Therefore x1 is the answer. We have to find x1 and we got x1 to be 10,208. Number 2, 10,200. Yes, that is the correct answer. Okay, now let us solve the next question. Now, as I told that proving properties, such kind of sums will not be asked, so those questions we will not do. Okay, so now directly question number 13, first one I will solve. Okay, so here matrices A and B are given. We have to show that, verify that one is the inverse of the other. Okay, so A is the inverse of B or B is the inverse of A. In this way we have to verify, yes or no. So obviously if we multiply a matrix and its inverse, we get the identity matrix. So we will do nothing but we will multiply the two matrices. We will find out product AB, BA and check. Okay, so let us find out product AB first. Minus 1, 1, 1, 1 minus 1, 1, 0, 1 by 2, 1 by 2, 1 by 2, 0, 1 by 2, 1 by 2, 1 by 2, 0. Okay, let us multiply 0 plus 1 by 2 plus 1 by 2, then minus 1 by 2 plus 0 plus 1 by 2, minus 1 by 2 plus 1 by 2 plus 0, again 0 minus 1 by 2 plus 1 by 2, 1 by 2 plus 0 plus 1 by 2, and 1 by 2 minus 1 by 2 plus 0, again 0 plus 1 by 2 minus 1 by 2, 1 by 2 plus 0 minus 1 by 2, and 1 by 2 plus 1 by 2 plus 0. So you will notice that we will get 1 0 0 0 1 0 0 0 1, okay, which is equal to I3, and therefore product AB is equal to I3. Okay, so we know that A into A inverse or A inverse into A is equal to I. Yes or no? So A into B. So B is the inverse of A, we can say, clear? Or A is the inverse of B anyway. Okay, so we'll write down, and therefore B is the inverse of here. So we have solved this. Now let us solve the next question. Okay, now I will solve question number 15, first one. Matrices A and B are given. We have to verify that BA is equals to 6 into I. If 91 is printed, you can correct and write down 6 into I. Clear? So do that correction if not done yet in your textbook. Okay, now question number 15. Matrix A is given to be 1 minus 1 0 2 3 4 0 1 2. Matrix B is given to be 2 2 minus 4 minus 4 2 minus 4 2 minus 1 5. Okay, we have to verify that BA is equal to 6I, and then we will find using the result solve the set of linear equations. So let us first verify that BA is equal to 6I or not. So BA is equals to matrix B 2 2 minus 4 minus 4 2 minus 4 2 minus 1 5 into 1 minus 1 0 2 3 4 0 1 2 is equals to 2 1s are 2 plus 4 plus 0 minus 2 plus 6 minus 4, then 0 plus 8 minus 8 minus 4 plus 4 plus 0 minus 4 plus 6 minus 4 minus minus plus 4, then 0 8 minus 8, again 2 minus 2 plus 0 minus 2 minus 3 plus 5 and 0 minus 4 plus 10. Okay, so we'll get 6 0 0 0 6 0 0 0 6. Taking 6 common, we get 6 into 1 0 0 0 1 0 0 0 1 is equal to 6I, hence proved. Okay, so first result is proved. Since BA is equal to 6I, therefore we have proved BA is equal to 6I, therefore 1 by 6B into A is equal to I. Yes or no? Okay. Or we can say that inverse of A is 1 upon 6B. Clear? Yes or no? So inverse of A is 1 upon 6B, or inverse of B is 1 upon 6A. Any one way you can take the result. But what to consider, that depends upon the given equation. So let us check what equations are given. Now we have to solve a system of equation using this result. Okay, so x minus y is equal to 3. 2x plus 3y plus 4z is equal to 17, and y plus 2z is equal to 7. Okay, so let us write down a matrix equation for this. therefore 1 minus 1 0 2 3 4 0 1 2 into x y z is equals to 3 17 and 7. Okay, let us look at this matrix. This is equivalent to matrix A, yes or no? Okay, this is equivalent to matrix A. This is matrix A only. So let us name this matrix to be X and this matrix to be C, because B is another matrix which is given. Okay, so now in order to find value of X, we have to calculate A inverse into C, yes or no? So okay, here matrix A is 1 minus 1 0 2 3 4 0 1 2. Matrix X is x y z and matrix C is 3 17 7. Okay, and therefore X is equal, okay, equation, matrix equation is Ax is equal to C, implies X is equal to A inverse C. So now we have already got the A inverse. What is A inverse? 1 upon 6 into B. So for A inverse we will put what? 1 upon 6 into B. Okay, so using 1 we can write down. Therefore X is equal to 1 upon 6B into C. So let us write down now 1 by 6B. 1 by 6 into matrix B is given 2 2 minus 4 minus 4 2 minus 4 2 minus 1 5 and C is 3 17 and 7. Okay, now this multiplication will show on this side only. Okay, 3 2s are 6 plus 34 minus 28 minus 12 plus 34 minus 28 and 3 2s are 6 minus 17 plus 35 is equal to 40 minus 30, so 12. Okay, then 28, 6 minus 6, okay, and 18 plus 6. Okay, so therefore we have x, y, z is equals to, and therefore x is equals to 12 by 6, y is equal to minus 6 upon 6, and z is equals to 24 by 6 is equal to 4. So we got the three values to be 2, minus 1 and 4. This was question number 15. 2 minus 1 and 4. Okay, so done. Okay, so similar questions are there. Okay. Okay, so now next question we are going to solve. paste question number 20 directly. Okay, and then we will see what to solve next. Question number 20. Okay, now so there is a mistake in question numbers 20. There is some mistake in that. Leave that question. And 21, 22, these all proving properties, as I told not to do. Okay, now we will directly solve question number 23. Solve the given system of equations by matrix method. So that too we have done in the previous exercise, but still 2-3 questions from this exercise also we will do. Okay, so question number 24. Suppose second one we are taking x plus y plus z is equal to 3. 2x minus y plus z is equals to 2, and x minus 2y plus 3z is equal to 2. X, y, z, 2x minus y plus z, x minus 2y plus 3z, 3, 2, 2. Okay, done. Okay, let us write down these three equations. This system of equations as a matrix equation. So we have 1, 1, 1, 2 minus 1, 1, 1 minus 2, 3, x, y, z is equals to 3, 2, 2. Okay, now we'll multiply row into column. X ones are x, we are not going to multiply, we will find out the determinant of matrix, but let us first name them. First matrix, we will name it to be matrix A, 1, 1, 1, 2 minus 1, 1, 1 minus 2, 3. X is the matrix, column matrix involving x, y, z, and B is the column matrix involving 3, 2, 2. Okay, now Ax is equals to B, and therefore x is equal to A inverse B. Okay, now determinant of A, 1, 1, 1, 2 minus 1, 1, 1 minus 2, 3, 1 minus 3 plus 2 minus 1 plus 1, okay, is equals to minus 1, minus 5, minus 3, minus 9. So determinant of A is minus 9. Let us again check. We have done little bit quick. 1 minus 3 minus plus 2 minus 1, 3 2 are 6, minus 1, minus 4 plus 1. Okay, done. So minus 3 plus 2 will be minus 1, 5 minus 5. Okay, so it is minus 9 only. And now we will find out the adjoint of A. So now this is a 3 by 3 matrix. So in order to find the adjoint, we have to write the cofactor of each and every element. Remember, okay, don't skip that step. Show that step in the exam also. Okay, so what we will do here, from here we can start writing the cofactors of each element. Okay, now cofactor, starting row wise, cofactor of 1, first row. Yes or no? That is cofactor is minus 1. Cofactor of second one will be negative. Okay, 6 minus 1 is 5. So minus 5 cofactor of 1, A13. Okay, third element of first row. That is minus 4 plus 1 minus 3. Okay, and sign will be positive only. Then cofactor of 2. 3 ones are 3 plus 2, 5, but sign is negative. Cofactor of minus 1 with positive sign. 3 ones are 3 minus 1, 2. Cofactor of 1, here minus sign will have. minus 2 minus 1 minus 3, so minus minus plus 3 cofactor of 8 1 3, third row first element 1, so 1 plus 1 2, cofactor of minus 2, negative sign, 1 ones are 1 minus 2, so minus 1, so finally plus 1, cofactor of 3 with positive sign, minus 1 minus 2 minus 3. So we have got the cofactors of each and every element. Now we can write the adjoint as the transpose of the matrix of cofactors. Yes or no? So adjoint of A is equal to minus 1 minus 5 minus 3 minus 5 2 3 2 1 minus 3 whole transpose. Therefore adjoint of A is, remember the determinant was minus 9. Yes or no? So minus 1 minus 5 minus 3 minus 5 2 3 2 1 minus 3, and now A inverse is equal to 1 upon determinant of A into adjoint of A is equal to minus 1 upon 9 minus 1 minus 5 2 minus 5 2 1 minus 3 3 minus 3. Okay, so we have got the A inverse. Now in order to find x, we have to find A inverse B. Okay, therefore x is equal to A inverse B is equals to minus 1 upon 9 minus 1 minus 5 2 minus 5 2 1 minus 3 3 minus 3 into 3 2 2 minus 1 upon 9 minus 3 minus 10 plus 4. Okay, then minus 15 plus 4 plus 2, then minus 9 plus 6 minus 6 is equal to minus 1 upon 9 into minus 9 minus 9 and minus 9. Okay, so 1 1 1. Yes or no? So value of x y z each will be 1 1 1. Therefore x y z 1 1 1. Therefore x is equal to 1, y is equal to 1, and z is equal to 1. Okay, so this was question number 24, second one. Okay, now one more question I should solve because all are similar. Okay, so one from the word problems I can solve. ISC, let me solve ISC 2009-26B. This is the last question for this exercise because plenty sums of same kind we have solved, so no need to solve again and again the same kind of sums. Now 26B you will solve. Once you have understood very well the method of solving, then the more sums are for practice only. Yes or no? So we have done, I think, now enough practice of solving such sums. So question number 27, question number 26, second one, or number B, x plus y plus z is equal to 9. and the third equation is 2x plus y minus z is equal to 0. Okay, so let us write a matrix equation for this. 1 1 1 2 5 7 2 1 minus 1 into x y z is equals to 9 52 0. Okay, now let A is equal to the first matrix 1 1 1 2 5 7 2 1 minus 1. X is equal to x y z and B is equal to 9 52 and 0. Now Ax is equals to B and therefore x is equals to A inverse B. Okay, now determinant of A we will find out 1 1 1 2 5 7 2 1 minus 1 is equals to 1 minus 5 minus 7 minus 1 minus 2 minus 14 plus 1. Okay, is equals to minus 12 plus 14 plus 16 then minus 8. Okay, so 12 and minus 20 plus 16 minus 4 not equal to 0. Minus 5 minus 7. Okay, this is 12 only. Minus 12, that is right. Minus 1 into minus 2 minus 14 minus 16, so plus 16 and then 2 1 2 minus 10, that is minus 8. Okay, now we will write down the cofactors. We will find adjoint of A. Okay, so starting cofactor of 1. Okay, that is minus 12. Cofactor of 1, that is 16. Cofactor of 1 A13, that is minus 8. Okay, cofactor of 2, minus 1 minus 1 minus 2, so minus minus plus 2. Cofactor of 5, minus 1 minus 2 minus 3. Cofactor of 7 will be 1 minus 2 minus 3, so minus minus plus 3. Cofactor of 2, 7 minus 5. Cofactor of 1, 7 minus 2 minus 5. Cofactor of minus 1, 5 minus 2, 3. So we got all the cofactors of 9 elements. Okay, now we can write down the adjoint of A as adjoint of A is equals to minus 12, 16 minus 8, 2 minus 3, 2 minus 5, 3. Transpose is equals to minus 12, 16 minus 8, 2 minus 3, 3, 2 minus 5, 3. This is adjoint of A and therefore A inverse is equals to 1 upon determinant of A into adjoint of A. Adjoint of A, determinant of A was minus 4, yes or no? So now X is equals to A inverse B. So what is A inverse? Okay, here let me write down minus 12 to 2, 16 minus 3 minus 5 minus 8 3, 3. So minus 1 upon 4 minus 12 to 2, 16 minus 3 minus 5 minus 8 3, 3 into 9 50 to 0. Okay, 108 plus 104 plus 0, 144, 156 plus 0 minus 72 plus 156 plus 0. Okay, now here minus 4. We are left with x, y, z is equals to minus 4 minus 12 and 72. 72 to the 144 plus 12. So 72 plus 12 will be 84. Yes or no? So 84, therefore x is equal to 1, y is z is equal to minus 14. Clear? So we got the three values. X is 1, y is 3 and z is 14. This is 26b. Okay, 1, 3 and 5 we are getting. So there must be some mistake. Now let us find out where is the mistake. 52 3s are 8 9 the 72. Okay, 144 minus 72. We got 84. 84 plus 72, 156. That is right only. So there must be 20. Yes or no? So in order to get 20, what is the mistake, that let us find out. Nine. Okay, so either there is a mistake with this 3. Now what is this 3? If we convert into row into column, then third column 2 3. Yes or no? Here we will come. So cofactor of 7 we have to check. Okay, in order to check the cofactor of 7, we will get 1 1s are 1 minus 2. Okay, so 1 1s are 1 minus 2. If you get, then minus 1 will come. Okay, and minus minus plus 1. So here suppose if we write 1, then what happens? Now let me check. Okay, 52. So yes, now we got. So there was a mistake. What was the mistake? The mistake was in writing the cofactor of 7. So you make the correction that cofactor of 7 is 1 only. Clear? And therefore now you will come to know that 1 into 52, 52. So here we will get 20 minus, and therefore the answer of z will be 5. Clear? So this is done. So with this exercise is over. Clear? Only take care while finding the cofactors, because there are the only chances where you might do mistake as I have done. Okay, so you have to take utmost care while finding the cofactors. Clear? So with this exercise is over. Now one last exercise using elementary row transformation. However, along with the explanation, I have explained you one or two examples, but still two examples of 2 by 2 matrix and one or two examples of 3 by 3 matrix. So total 4 examples we can solve to understand. Okay, and remaining you can practice yourself. So it will take one more period to complete this full chapter. So in the next video I will finish this chapter. Okay, by that time take care. Thank you very much.